In a rare and unprecedented occurrence, astronomers and scientists have recently observed a major piece of the sun detaching from its surface, raising concerns about potential dangers for Earth. As the primary source of light, heat, and energy in our solar system, the sun plays a critical role in sustaining life on our planet. Any significant disruptions or changes in the sun's behavior can have far-reaching consequences for Earth and its inhabitants. This unexpected event has sparked a flurry of scientific inquiries and has prompted a deep exploration of the potential dangers posed to our planet. In this comprehensive video, we will delve into the scientific intricacies behind the detachment of the sun's fragment, examine the potential risks associated with it, and explore the implications for Earth. Solar flares and coronal mass ejections. Solar flares and coronal mass ejections, CMEs, are two phenomena closely tied to solar activity that can directly affect Earth. Solar flares are intense eruptions of electromagnetic radiation that occur near sunspots. They release massive amounts of energy, including X-rays and ultraviolet radiation, and can be accompanied by bursts of high-energy particles. Coronal mass ejections, on the other hand, involve the expulsion of billions of tons of plasma, magnetic fields, and charged particles from the sun's corona into space. When a significant fragment breaks off the sun, it can lead to an increase in solar flares and CMEs. These events can have several potential impacts on Earth, including disruptions to satellite communications, interference with radio signals, and damage to power grids. Solar storms caused by CMEs can induce geomagnetic disturbances on Earth, affecting technological systems such as satellite navigation, electrical power transmission, and even aviation. Electromagnetic radiation and solar wind. The detachment of a major piece of the sun can result in a release of substantial amounts of electromagnetic radiation and solar wind towards Earth. Electromagnetic radiation consists of a wide range of wavelengths, including radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. While Earth's atmosphere provides some shielding against this radiation, particularly in the form of the ozone layer, intense bursts of electromagnetic radiation can still reach the planet's surface. This can pose health risks to humans, including increased incidences of sunburns, cataracts, and potential long-term effects such as an elevated risk of skin cancer. Additionally, the detachment of a major piece of the sun can result in intensified solar wind, a stream of charged particles flowing outward from the sun. This increased solar wind can interact with Earth's magnetosphere, the region around the planet influenced by its magnetic field. Disruptions in the magnetosphere can lead to geomagnetic storms, affecting satellite operations, spacecraft navigation, and power grids. Impact on climate and weather. Solar activity has a significant influence on Earth's climate and weather patterns. While the exact mechanisms and the extent of this influence are complex and continue to be the subject of ongoing research, there is evidence to suggest a correlation between solar variability and certain climate phenomena. The detachment of a major piece of the sun can contribute to shifts in global climate patterns. Solar radiation affects the Earth's atmosphere, influencing temperature distributions, wind patterns, and ocean currents. Changes in solar output, including fluctuations in the sun's energy emissions, can potentially impact the Earth's energy balance and alter the dynamics of the climate system. Solar radiation also plays a crucial role in the formation and maintenance of the Earth's ozone layer. The detachment of a significant piece of the sun could potentially affect the ozone layer's composition and stability, which in turn could have implications for the amount of ultraviolet UV radiation reaching the Earth's surface. Excessive UV radiation can be harmful to living organisms, leading to increased risks of skin cancer, damage to marine ecosystems, and disruption of terrestrial plant life. Furthermore, variations in solar activity can impact the behavior of the jet stream, a high-altitude wind system that influences weather patterns. Changes in the jet stream can lead to shifts in atmospheric pressure patterns, altering the distribution of precipitation, temperature gradients, and storm tracks. These changes can potentially result in an increased frequency or intensity of extreme weather events, such as heat waves, droughts, storms, and floods. Potential precautions and mitigation strategies. To minimize the potential dangers associated with a detached piece of the sun, it is crucial to develop robust precautionary measures and mitigation strategies. Early warning systems and sophisticated monitoring technologies provide vital information about incoming solar flares, CMEs, and geomagnetic disturbances, allowing utilities, governments, and individuals to take proactive measures. Space-based observatories, such as the Solar Dynamics Observatory, SDO, and the Solar and Heliospheric Observatory, SLHO play a crucial role in monitoring the sun and providing real-time data on solar activity. Strengthening critical infrastructure such as power grids, satellite systems, and communication networks can enhance the resilience to solar-induced disturbances. This includes implementing protective measures such as shielding sensitive equipment and developing protocols to temporarily shut down or reroute critical systems during periods of heightened solar activity. Additionally, advancing space weather forecasting capabilities can enable satellite operators to adjust orbits and protect onboard electronics, minimizing potential damage from solar radiation and geomagnetic disturbances. Public awareness and education about space weather are vital components of preparedness. By disseminating information about solar activity, potential risks, and precautionary measures, individuals can take steps to protect themselves and their electronic devices during periods of heightened solar activity. Collaborative efforts among scientific institutions, governments, international organizations, and industry stakeholders are essential to strengthen our understanding of space weather phenomena, improve forecasting models, and develop effective strategies for mitigating potential risks. The detachment of a major piece of the sun raises valid concerns about the potential dangers for Earth. Solar flares, coronal mass ejections, electromagnetic radiation, solar wind, and their impacts on climate and weather patterns all pose risks to our planet and its inhabitants. However, the continued research, technological advancements, and the implementation of appropriate precautionary measures, we can enhance our ability to predict, understand, and mitigate the potential consequences of solar events. By increasing our preparedness, improving infrastructure resilience, and raising public awareness about space weather, we can reduce the impact of solar disturbances on critical systems and safeguard human health, technology, and the environment. As we continue to explore the complexities of our dynamic sun and its interactions with Earth, it is essential to remain vigilant and proactive in our approach to space weather. By fostering international collaboration and investing in space weather research, monitoring, and preparedness, we can mitigate risks, improve our resilience, and ensure the continued safety and well-being of our planet in the face of solar phenomena. So that's it for today. If you liked this video, then please hit the like and subscribe button for more videos. Thanks for watching.